Hello science students, Mr. Grange here. First video made of the 2020-2021 school year. Very excited to be here. Today I'm just going to talk about measurement and significant digits. Okay? Two of my top 20 things to talk about. Here's a little definition for you. I'll have to read. I'll read it to you. The intellectual and practical activity encompassing the systematic study of the structure and behavior of the physical and natural world through observation and experiment. Okay, so we're going to talk about these italicized things today. What this is a definition of science. If you don't believe me, check the dictionary. First word here, systematic. When we're talking about science, we talk about systems. We talk about the entire scientific community. Talk about this entity that is science and how systematic it is. The most basic and most important thing that we use is the international system, or the SI, as we like to call it. Why is the international system abbreviated SI? Shouldn't it be IS? The answer is no. It's actually a French phrase meaning Le Système International des Unités. My best French reading there. Or, as I like to call it, a little more simplified version, the metric system. Right, the system that we use to that all scientists use to communicate to every other scientist on the face of the globe. Next word here is observation. What is observation? Obvious definition, looking at something, watching something, seeing something, right? But if we look at it a little more detailed, there's a couple ways we can make observations. One of them is the qualitative way. This is looking at qualities or non-numerical descriptions of a distinguishing characteristic, right? So you can describe the color, the taste, the smell, the non-numeric description, right? What we're going to look at a little more today, though, is the quantitative. When we say quantitative, this is the numbers. This is the measurement, right? This is using those units. Numerically comparing something to a scale or standard, right? Standard being that system, the international system that we use. Those would be all the fundamental units that we'll learn about probably in the next video. Okay, so qualitative, non-numerical description. Quantitative, right? Quantity is that measurement, those numbers that go along with it, this set, standard set of units that we can use. Okay. So let's just say we're measuring something such as this green shape here. We could measure the length, the width. Maybe it has 3 dimensions. We can measure the area. We can measure the volume, right? We're just going to measure one side of this today. Okay, we're going to measure the length. A couple things before we do that. Every measurement that you take has some uncertainty, some degree of uncertainty. It means there's some unknown. And as a scientist, it is your job, it is every scientist's job to make this as uncertain as possible. Okay, but you still have to estimate one digit. You always estimate one number. Okay. Oops. And what it comes down to essentially is the tool that you're using. Alrighty. It's all about the tool. You can get really expensive tools. You can get really cheap tools. Hopefully you've gotten a ruler by the time you've seen this video. But really it comes down to the tool. The more expensive a tool, the more accurate you can probably measure. Okay. Excuse me. So, what you have to do is read between the lines. What does this mean? Let me show you. First, you've got to get your tool. Say you have, on this program, it calls it math tools. But let's say we got a ruler here to measure this side. Okay. This ruler here I have has a side that is inches and one side that is centimeters. I'm going to start with centimeters here, just to give you an idea here. And so, of course, when you're measuring something, you put it up to the end on one side, and then you can look on the other side to see. Okay, and so when I was talking about certain and uncertain numbers, this is what I'm talking about here. As you can see, where I have the centimeters here, you have lines. Okay, and we know for certain, 100%, that this green object has a length that is bigger than 9 but less than 10. So we know for certain that this is going to be 9 point something centimeters. Okay, so this is a certain digit. Now it's our job, if you notice, there's a pretty big space between 9 and 10. It's our job as good scientists, quality scientists, to estimate between these two lines, 9 and 10, as best that we can. Okay, and I'm going to eyeball this. Looks like it's a little less than half, so I'm going to say 9.4 centimeters. Okay, that would be the correct answer for what's the length of this green object. Maybe your lab partner thinks it is 9.3 centimeters. Maybe your other lab partner thinks that it is it says there it's half. It's 9.5 centimeters. Okay, which one would be correct? All of them. Right? It's our job as scientists to estimate as best we can. It's not perfect. This second digit here in the tens place, in this case, is the uncertain digit. Alrighty? If someone was to say, one lab partner said, no, I think it's 9.45. I don't think it's halfway, but it's a little bigger. That would be incorrect. You cannot estimate if there's no lines. You can only have one uncertain digit. You can have lots of certain digits, right? An example here, if this was millimeters instead of centimeters, now, right, I know that it is between 9 centimeters and 10 centimeters, or 90 millimeters and 100 millimeters. But now it's my job to look at this and say, okay, well, there's lines for this. I know that it is, looks like let's cheat a little bit just so you get the idea here. If I zoom in, it's maybe even bigger. If I zoom in here, right, you could do this with a magnifying glass or something. You can see that it looks like it's going past the 0.5 mark there just a bit. So I would say this is 9 point, now that I have more lines, my tool has improved. I spent more money on my tool, comes down to the tool. Now I have to read between these little lines. I know that it is between 5 and 6, so I can say 9.5. And I can actually, I could say, you could either say 9.50 would probably be correct, but it looks like it's just barely past there. I'm going to say I'm going to say that it is 9.51. Okay, I'm going to say this is 9.51 centimeters. I couldn't say 9.512. That'd be incorrect. I have 2 certain digits and 1 uncertain. You always have 1 certain digit. Okay, so this would give me a total of 3 significant digits. Uncertain digits are significant because we trust that every scientist that is taking a measurement estimates it to their best ability. Let me come back here. Okay, so that's what we mean between, it all comes down to the tool. You have to read between the lines, okay? And you have to have those certain and uncertain digits, okay? Reiterate this. You must read between the lines to be a good scientist. Let me move my face around. So, you have certain digits and you have uncertain digits, okay? Certain digits are numbers that you have lines for and you know it's bigger than or smaller than. And then your one uncertain digit is that estimated digit, and you can only have one of those. Always. You can have hundreds, tens, hundreds, certain digits, but you can only have one uncertain digit because you can only read between 2 lines when it comes down to it. Now, sometimes, that's when you measure. That's where significance, that's how rounding works in science. Okay. If you ever asked your science teacher, what do I round to? Depends on the tool. All comes down to the tool. You round to wherever that uncertain digit is. Okay, But a lot of times in science class, you're given values, you're given numbers, or if you're reading a scientific paper, sometimes you have data that you are given. And in that case, you have to know these significant digit rules, okay? So they are as follows. There's 4 of them. 2 always, 1 never, and an only, okay? So this is when you have a number. So let's just say we had a number. We had a number 12, okay? 12 centimeters, maybe it was our measurement. All non-zero digits are significant, always. Non-zero digits are always significant. So this would have 2 significant digits, okay? So we have 2 SD, okay? Leading zeros are never significant. People get confused by this one a lot. Some changing colors. Let's say you had a 0 in front of the 12. 0, 12 centimeters. Would that be significant? Is that part of your measurement? No, it's not. There's no certain digit for that, right? It doesn't mean anything. Okay, so leading zeros are never significant. Even if it's something like 0.12 centimeters, still has 2 significant digits. Zeros are never significant. Leading zeros are never significant. Never. Okay. What if you had 102 centimeters? A trapped 0. This would be, now you have 2 non-zeros, those are significant always, and 1 trapped. So this has 3 significant digits there. 3 SD. Okay. Now the last one is the hardest one. Trailing zeros are significant only when there's a decimal point. Okay. So trailing zeros, this is when I say leading and trapped and trailing, it's all based on those non-zero digits, not the decimal. It's all related to that non-zero digit. That's what we're talking about. That's what it's in reference to. So if I had 12.0 centimeters, okay, that would be 3 significant digits. That's 3 significant digits. That is a leading zero, and there's a decimal. Or if you had 0.120 centimeters, it's kind of similar to that first one, this one here. Leading zero, not significant, but there's a leading zero of the whole numbers, not the decimal, right? Because it could be 0.0120. Leading zeros, neither of those are significant, even though there's a decimal. Trailing zeros are. So this would have 3 significant digits, as would this. 3. Okay, so those are the rules. Write those down. You can always refer to those. That concludes this video. Can't wait to see you next time. Have a wonderful day, and keep on learning. Mr. Grain Job.